that's forces. We also have to think about moments acting. And a moment is a tendency of a force to cause rotation about a point or a line. So say I have a point down here, called the point O, and I have some force that's acting like that. That force is going to tend to cause some rotation around the point O, and I can calculate the moment, which is a vector, by taking the cross product of the vector r between the point O and the point of application of the force F. So let me write that down. So the cross product is useful if we have a situation in 3D, but often we have a two-dimensional situation, and then there's a somewhat simpler way you can do it. So I'll just say the cross product is useful in 3D. In 2D, we can get the magnitude of the moment by taking the magnitude of the force and multiplying it by the perpendicular distance between the point O and the line of action of the force. So say this is the line of action here. If I just extend that backwards, the perpendicular distance, let's see, let me call that r down there. My perpendicular distance here is d. So the magnitude of the moment is just the magnitude of the force times that perpendicular distance d. So we can say the magnitude of m is just the magnitude of F multiplied by that distance d. And the direction is given by the right-hand rule. So do you remember the right-hand rule? You put your thumb on the point O that the rotation is about. You curl your fingers in the sense of the rotation. If your thumb, well, you can have different conventions, but the convention I use is if your thumb points in, it's negative, and if your thumb points out, it's positive. So if you have a a rotation that's counterclockwise, your thumb's pointing out. And that's a positive rotation. If your thumb is pointing into the board, that's a clockwise rotation, and that's negative. Oops. Like that. Okay? So the only trick is remembering to use your right hand. So I see students during the test, they're using their left hand. Problem.